Okay, so in today's lesson, we are going to talk about what happens when we try and factor and we don't get that 1 in front of our x squared like we like to have. So it says when we are factoring, don't forget the first step. Our first step is always to pull out the GCF. So we always do that first. So the first thing I'm going to look for is my GCF. So I've got 15, -10, and -25. Well, I should notice that 5 will go into all of those. So I'm going to pull out a 5 first. So I'm going to have a 5 out here. And then I'll have 15 divided by 5 will leave me with 3p squared. -10 divided by 5 will leave us with -2p. And -25 divided by 5 is -5. Okay, so normally at this point we would identify our sum and our product. So our sum is the middle number, -2, and our product is our last number, which is -5. All right, so I would bring down my GCF and I'm going to make 2 sets of parentheses. So this part is where it's different because normally right here we would have 1p squared, or it just would say p squared. If it does not have a 1 right here, then we cannot use our rule that we've used before. So what we have to do is we still look at this number and we have to decide what we could use to multiply to get -5. Well, the only thing that multiplies to give us 5 is 5 and 1. So we do know that one of these needs to be negative, but we're not trying to add to get -2 because there is no way to add 1 and 5 and get -2. So what we do is we look at this term to decide what we put in the front. Normally we would just put p and p, or x and x, but that's when we just have a p squared or x squared. Now I need something that multiplies to give me 3p squared. So that would be 3p and 1p. 3p times p would give me 3p squared. All right, so now what we do is we plug in these two numbers that we got right here. So I'm going to just go ahead and put them in my parentheses. Now, to check to see if they are in the right spot, you check the inner part of your parentheses and the outer part of your parentheses. So what I mean by that, this is my inner right here, these two things. So what is 1 times p? Well, that would be 1p. And then you check the outer part of your parentheses. 3p times 5p, that would be 15p. Is there any way you can make 15 and 1 give you -2? No, no way. So we must have had them in the wrong spot. So I've got my 5 here, make my 2 sets of parentheses, and we still have to keep the 3p and p because this has to multiply to give us 3p squared. But this time, I'm going to put the 5 in this one and the 1 in the second set. So now I check the inside. 5 times p would give me 5p. And then I check the outside. 3p times 1 would give me 3p. And can I make 5p and 3p give me -2? Yes, I can. If I want a -2 when I add those together, I would need -5 plus 3. Now the 5 came from here. So I would need to put the negative with that 5. And the 3p came from here, and I want it to be positive, so I would put the positive there. So my answer would be 5 times 3p minus 5 times p plus 1. So sometimes you just have to try it, see if it works, and if it doesn't, switch things up. So let's try another one. Number 2, first step, always pull out a GCF if there is one. So I look for a GCF. I'm looking and it does not look like there's anything I can pull out of all these, so no GCF. So I look at my sum, which is 3, and my product, which is -9. All right, so I need something that multiplies to give me -9. Well, the only thing that multiplies to give me 9 besides 1 and 9 is 3 and 3. But one of these has to be negative, and if I make it negative, -3 plus 3, that will give me 0. So that's why we have to use our rule that we talked about in our last question. So there was no GCF, so I go ahead and I make my 2 sets of parentheses. The first thing in my parenthesis has to multiply to give me 2n squared. So last time we needed 3p, and we put 3p and 1p. This time I need 2n squared, so I'm going to put 2n and n. All right, now I'm going to plug in my numbers, 3 and 3, and we check the inner, just like we did here, and the outer. So the inside, 3 times n would give me 3n, and the outside, 2n times 3 would give me 6n. So now I'm thinking, is there a way that I could add 3n and 6n and get a positive 3? Yes. If this was a -3 plus 6, that would give me 3n. So the 3n came from here, so that's where I'm going to put my negative. The 6n came from here, so that's where I'll put my positive. So my answer here would be 2n minus 3 times n plus 3. All right, number 3. First thing I look for always is a GCF. So it looks like no number, but they do all have an x. So I'm going to pull an x out of all of these. So if I pull out an x, I would have 3x squared minus 8x plus 4. So that would mean that my sum is -8 and my product is 4. So we do know that 2 times 2 gives us 4, but 2 plus 2 does not give us 8. So we have to plug it in and check the inner and outer and make sure we put them in the right spot. So we pull down our x and make our 2 sets of parentheses. We need something that will give us 3x squared in the front. So it's going to be 3x and x. And then I plug in my 2 and my 2. Now we check the inner. 2 times x would give us 2x. And I check the outer. 3x times 2x would give me 6x. And I need these two things to add up to -8. Well, if I make them both negative, then that would work. -2 minus 6 is -8. So I go put in my negatives. And if I was to FOIL this back out, -2 times -2 would give me +4. So my answer here would be x times 3x minus 2 times x minus 2. All right, let's try another one. Okay, number 4, we look for a GCF. So it does not look like there's anything I can pull out of those. So my sum is 19 and my product is 12. So there's a couple of things that multiply to give us 12. Maybe we think 6 and 2 first. And we know that 6 plus 2 doesn't give us 19, but we have to check inner and outer to see if we're right. So I would come over here. I'm going to make my 2 sets of parentheses. In the front, we need something that's going to give us 5n squared. So that would be 5n and n. All right. So let's plug in our 6 and 2. And we're going to check the inner, which would give us 6n, and the outer, which would give us 10n. So now we think, is there any way for 6 and 10 to give us 19? And there's not, right? So maybe we put the 6 and 2 in the wrong place. Let's try just switching where the 6 and the 2 are. So I'm going to put the 2 here and the 6 here. So let's give that a try. So now the inner would give me 2, and the outer would give me 30. 2 in and 30 in still doesn't give me 19. So that must not be right. So 6 and 2 didn't work. What else multiplies to give us 12? We could use 3 and 4. So we make our 2 sets of parentheses. Remember at the front we use 5 in and in. And we can try our 3 and 4. So I check the inner. This is going to give me 3 in. And I check the outer, and this gives me 20 in. So 3 and 20. There's no way to make that give me 19. Okay, so let's try again. Switch our 3 and 4. Okay, so if I switch the 3 and 4, now the inner is going to give me 4 in, and the outer would be 5 in times 3, which is going to give us 15 in. And can we make 4 plus 15 give us 19? Yes, they just both need to be positive. 4 plus 15 is 19. So we finally found the right match. So 5 in plus 4 times in plus 3. So we may not always choose the right numbers on our first guess. So it takes a little trial and error to make sure that they work. So when you check your inner and outer, it has to give you numbers that you could add up in some way to get your sum. All right, number 5. I look for my GCF. So it looks like 10, 22, and 4, those are all numbers that are divisible by 2, and they all have a V in them. So I'm going to pull out a 2V. Well, 10 divided by 2 is 5, and if I take out a V, I have V squared. 22 divided by 2 would be 11, and if I take out a V from V squared, I just have 1V. And 4 divided by 2 is 2, and I took out the only V. So that means that my sum is 11, and my product is 2. So we need something that multiplies to give us 2. Our only options would be 2 and 1. But 2 plus 1 does not give me an 11, so we're going to have to make sure we check the inner and outer. So we pull down our GCF, and we make our 2 sets of parentheses. We need something that multiplies to give us 5V squared. So that would have to be 5V and V. And then we're going to have to try our 2 and 1. So 2 times V would give us 2V, and 5 times V, or 5V times 1 would give us 5V. And 2V plus 5V does not give me 11. So I did this in the wrong order. Let's try again. 5V and V, and I'm going to put the 1 here and the 2 here. So I check the inner, that's going to give me 1V. I check the outer, that gives me 10V. And I can make 1 plus 10 give me 11 if I just put a plus sign with each one. So my answer is 2V times 5V plus 1 times V plus 2. All right, last one. So the first thing we look for is a GCF. So 2 would go in here and here, but 2 does not go into 5. So it looks like we do not have a GCF here. So our sum is that middle number 5, and our product is our last number 2. So I need to break this into 2 sets of parentheses. At the front of my parentheses, we need something that multiplies to give us 2n squared. So that would have to be 2n and in. Then I need something that multiplies to give me 2. So that would be 1 and 2. So I plug in my 1 and I plug in my 2. I check the inner, that's going to give me 1 in. And I check the outer, that gives me 4 in. And I need 5. Well, I can make those both positive. And I get 5. So my answer would be 2n plus 1 times n plus 2. So we got lucky on that one and we picked the right numbers the first guess. Again, remember you will not always get the right answer the first time. See here, we tried it with the 6 here and the 2 here, that was wrong. Then we switched it, 2 and 6, still didn't work. Then we tried 3 and 4, that didn't work. We finally switched it to 4 and 3 and it worked. So it may take a few guesses to get it right, but then you may happen to, sometimes like we did here, get the right answer on the first guess. But make sure that you always check the inner and the outer to be something to add to get you your sum.